Good morning everyone. I am Maheshwari Manepatil. Today I am here to present presentation on topic combined base isolation system. Firstly, we will see what is base isolation system. A base isolation system is a method of seismic protection where the structure is separated from the base. By separating the structure from its base, the amount of energy that is transferred to the superstructure during an earthquake is reduced significantly. There are mainly three types of base isolation system. First is elastomeric base isolation, second sliding base isolation, and the last one combined base isolation. Here are some advantages of base isolation techniques. Apart from protecting structures from seismic activities, base isolation also protects them from GSA blast loads as the ability to move reduces the overall impact of the blast on the structures. Base isolated structures are predictable, hence reliability of them is very high as compared to conventional structural components. Need of strengthening measures such as frames, bracing, and shear walls in cut down by reducing the earthquake forces transmitted to the building. Simplification of seismic analysis as, a, as compared to the conventional structure by allowing reduction in structural. Here are some disadvantages of base isolation techniques. Base isolation can't be done on every structure. For example, it is not suitable for structures resting on soft soils, becomes less efficient for high-rise buildings. Unlike other retrofitting, base isolation cannot be applied partially to the structures. Implementation is efficient efficient manner is difficult and often requires highly skilled laborers and engineers. Now we will see combined base isolation system. With regard to the earthquake, the insertion of very flexible base isolation system is generally favorable. Laminated rubber bearings and sliding rubber bearings are most frequently utilized since they can provide suitable horizontal flexibility, but because of the vertical strength limit, the many bearings in isolation system should lead to great lateral stiffness. Otherwise, sliding rubber bearings possesses high initial stiffness and very low post yielding stiffness, which would cause unexpectedly large displacements of structures after sliding occurs and residual displacement after earthquake. So combined isolation composed of LRB and SRB is developed in order to satisfy serviceability under low intensity earthquakes and wind loads and response reduction under strong earthquakes. Thank you.